This is a continuation of the previous problem. As per the previous problem, suppose this sphere sits in a uniform magnetic field with springs B. If the sphere's magnetic moment is displaced a small angle from this field, what is the period of oscillation? So, in order to do this problem, you have to need one more piece of information, which is just assume that the mass of the sphere, which I have given you. So let's say the mass of the sphere is m. Okay, and then if we do that, we can basically do this problem. So I apologize for not including this information in the question itself. All right, so to do this problem, let's basically note that the torque is equal to mu cross with the B field, right? And there's some small displacement of the B field. So let's imagine this is your sphere. It's rotating around with some omega, and now you're suddenly there's a B field, which is like this direction, and this angle here is theta, and theta is very, very small. Okay, so if this were the case, all right, let us calculate this. This, all right, as you recall, right, is going to be equal to I times alpha, right, where I is the moment inertia and alpha is the angular acceleration, right? Okay, so if we do this correctly, we found out last time that the magnitude of mu, so magnitude of mu is basically just 2/5 q r squared times omega, right? And now what I'm going to do is to cross this with the B field, right? But this thing for small angles is just going to be 2/5 q r squared omega B field sine of theta, right? Okay, so this I times alpha is really just, what is I for the for a solid sphere? That's just 2/5 mr squared, right? Times alpha, which is just theta double dot, is equal to 2/5 q r squared omega b. Okay, well, let's just cancel out some terms here. Now, sine theta. Okay, now one thing what we have to be careful about is that this equation itself is not solvable. So, using the condition that theta is much, much less than 1, you can approximate this as sine theta is roughly theta. So this becomes just 2/5 q omega b theta. And so what you end up having is that m theta double dot is equal to q omega b theta. Okay? And so let's rewrite this equation, something simple. Is equal to, so divide by m on both sides. So this is going to be q omega b over m theta. Now, recall our simple harmonic oscillator equation. So the simple harmonic oscillator was basically x double dot is equal to minus, and I have to be careful. There is a minus sign here. Okay. X double dot is equal to minus omega squared x. All right. The minus sign will come from this, from the cross product, but I'm just not going to worry about it. You can just take my word for it. There should be a minus sign that appears here. All right. So minus omega squared x. So if you have this, you can plug it in, right, and just identify x is just basically theta, and omega squared is just basically this. So that means that omega squared is equal to q omega b over m, right? Which implies that omega is equal to q omega b over m square root. Okay, hope that was helpful.